Welcome to the deep dive. Today, we're off to explore Mercury.
Ah, Mercury.
You might think Mercury, that tiny hot speck near the sun.
Yeah,
But trust me, there's way more to it than meets the eye, and we're about to find out.
absolutely.
We've got some fascinating excerpts from Wikipedia all lined up for you, ready to be unpacked.
Excellent choice. Mercury often gets overlooked,
Right?
but it's a goldmine of information about how planets form, how they evolve, plus it boasts some truly bizarre features.
Exactly. And for this deep dive, we're going beyond Mercury 101.
Okay,
You want the aha moments, the stuff that makes you see this planet in a whole new light.
right.
Think extreme temperature swings, that powerful magnetic field. And get this, there might even be ice on Mercury.
Precisely.
Yeah.
We're going to dig into those intriguing details and connect them to the bigger picture of our solar system.
Okay, let's get our bearings first.
Yep.
Wikipedia tells us Mercury is small, even compared to some moons.
It is tiny.
It's incredibly dense for its size.
Yeah.
What's the explanation there?
That density is key. That tells us a lot about Mercury's internal structure, which is surprisingly complex.
Okay.
Imagine this. You've got a golf ball and a ping pong ball, same size.
Okay.
The golf ball feels much heavier, right?
Right.
Because it's denser, more mass packed into the same space.
Makes sense.
Mercury's density tells us it must be made of heavier elements, mainly a large iron core.
So it's like a giant metal ball whizzing around the sun.
Essentially, yeah.
That's pretty cool. But if it's mostly iron, why isn't it smooth? The images from Wikipedia show a surface covered in craters.
Yeah,
It looks like it's been used for cosmic target practice.
it really does. And that's not far off, actually.
Oh.
That heavily cratered surface tells the story of billions of years of asteroid bombardment.
Wow.
But it's not all craters.
Really?
We also see smooth plains, kind of like the lunar Maria on the moon, but formed differently.
Ah. Here's where it gets interesting.
Right.
Tell me more about those smooth plains.
Okay.
How did they form?
So while the moon's Maria are mostly ancient lava flows, the smooth plains on Mercury likely formed from volcanic activity. But volcanic activity triggered by those massive impacts.
Interesting.
Speaking of impacts, have you seen the Caloris Basin?
The what?
The Caloris Basin. This colossal crater is over 900 miles wide.
900 miles.
Yeah, imagine the impact needed to create that.
Wow, 900 miles. That's enormous.
Huge.
Almost a third of the entire planet. It makes you wonder what other secrets are lurking beneath Mercury's surface.
Yeah, for sure.
Wikipedia mentions something called weird terrain on the opposite side of the planet.
Oh, yeah.
What's the story there?
That jumbled, chaotic landscape on the opposite side of the Caloris Basin?
Yeah.
Scientists believe it formed from seismic waves generated by the Caloris impact.
Wow.
Picture those waves converging on the opposite side of the planet, wreaking havoc on the surface.
Oh, wow.
It's a dramatic illustration of how a single event can reshape an entire planet.
So we've got a massive impact crater and a bizarre landscape on the opposite side, both linked to the same event billions of years ago.
Yeah,
That's incredible.
it's amazing what we can piece together, right?
Yeah. But the article also mentions wrinkle ridges. Those don't sound very impact related.
No, they're not, no.
What are they?
You're right, those are a different phenomenon.
Okay.
Think of a grape slowly shriveling into a raisin.
Okay.
That's essentially what happened to Mercury.
What?
As its core cooled and contracted over billions of years, the planet actually shrank.
The whole planet shrunk.
The whole planet shrunk, and those wrinkle ridges are the result of that planetary scale shrinking.
So we've got a planet with a massive iron core, a surface scarred by impacts, and wrinkles from shrinking.
It's a fascinating place, yeah.
Talk about a face only a mother could love. But this is where things get really wild.
Yeah.
Wikipedia mentions the possibility of ice on Mercury.
Yeah.
Ice
Guys.
on a planet that practically grazes the sun. How is that even possible?
That's where Mercury throws us a real curveball.
Okay.
You'd think with temperatures reaching 800 degrees Fahrenheit, ice wouldn't stand a chance.
Oh, way.
But Mercury has a trick up its sleeve. It's axial tilt, or rather, the lack of it.
Okay, I'm intrigued.
Yeah.
Tell me more about this axial tilt and how it could allow ice to survive on such a scorching world.
Okay, so Mercury spins almost perfectly upright, with its poles barely tilted relative to its orbit.
Okay.
This means that some crater floors at the poles are in permanent shadow. And in those perpetually dark craters,
Yeah.
it's cold enough for ice to survive, even on a planet where daytime temperatures could melt lead.
Wow, that's amazing. It's like finding an ice cube in a furnace.
It really is.
So you're telling me that on this scorching world, with temperatures hot enough to bake a pizza in seconds,
Yeah.
there are pockets of permanent darkness where ice has been hiding for billions of years.
That's exactly what we're saying, yeah.
That's mind-blowing.
It's incredible, isn't it?
But it gets even weirder, right? Wikipedia mentions that Mercury has a surprisingly strong magnetic field, even though it spins incredibly slowly.
It does, yeah.
Shouldn't a planet need to be spinning rapidly to generate a strong magnetic field?
It's a great question. You'd think a slow spinner like Mercury wouldn't have much of a magnetic field.
Right.
But here's the thing. The strength of a planet's magnetic field isn't just about how fast it spins, it's also about what's going on inside.
Okay.
In Mercury's case, the most likely explanation for its robust magnetic field is a dynamo effect, similar to what generates Earth's magnetic field.
So what is it about Mercury's interior that allows it to maintain this dynamo effect and generate such a strong magnetic field? Is it something to do with that large iron core we talked about earlier?
You got it. Remember how we talked about Mercury having a proportionally large iron core?
Yeah.
That core is key to its magnetic field.
Okay.
You see, the dynamo effect relies on the movement of molten iron in a planet's core.
Uh-huh.
And even though Mercury is small, its core is still partially molten, which is incredible considering how old the planet is.
So even though it's been billions of years since the solar system formed, Mercury's core is still partially molten, and that's what's driving this surprisingly strong magnetic field.
It appears so, yes.
That's fascinating. But this magnetic field isn't exactly like Earth's, is it? Wikipedia mentions something about magnetic tornadoes.
Oh, right, yeah.
Now that sounds intense. Yeah.
What are they and what do they do?
You're right. Mercury's magnetic field, it's got some unique quirks.
Okay.
The Messenger spacecraft, it actually discovered these bizarre twisted bundles of magnetic fields,
Okay.
connecting Mercury's magnetic field directly to the sun's magnetic field.
Directly to the sun.
Yeah, these are the magnetic tornadoes you're talking about.
Wow, that's intense. It's like a cosmic umbilical cord. What effect do these magnetic tornadoes have on the planet?
So they create openings in Mercury's magnetic field,
Oh, no.
allowing the solar wind, which is a stream of charged particles that's constantly flowing from the sun,
Right.
to reach the surface.
So even with a magnetic field, Mercury is still bombarded by the solar wind. That doesn't sound good. What kind of impact does that have on the planet's surface?
Yeah, not ideal.
That constant bombardment of charged particles from the sun, it causes something called space weathering,
Space weathering.
which alters the physical and chemical properties of the surface materials, making them look darker and redder over time.
So it's like Mercury's getting a constant suntan.
That's a good way to put it.
Instead of a healthy glow, it gets a weathered appearance.
Exactly.
A cosmic suntan. That's one way to put it. So we've got this tiny, dense planet with a battered surface, hidden ice, a surprisingly strong magnetic field, and to top it all off, it's getting blasted by the solar wind.
Jiggles.
Quite the resume, right?
Mercury is definitely a survivor.
It is.
But let's talk about its relationship with the sun.
Okay.
Wikipedia mentions that Mercury's orbit is more elliptical, more like an oval, than circular.
And that this has some pretty strange effects on its days and years.
Absolutely.
Okay.
Mercury's orbit is the most eccentric of all the planets in our solar system.
Wow.
And it results in some truly bizarre phenomena.
Okay.
For one, a day on Mercury is twice as long as its year.
Hold on. A day is longer than a year? That seems completely backwards. How is that even possible?
It really does, doesn't it? It's all down to the combination of Mercury's slow rotation and its elliptical orbit.
Okay.
It takes Mercury about 88 Earth days to orbit the sun once,
Okay.
but it takes about 59 Earth days for it to rotate once on its axis.
Oh, so it's like Mercury's taking its sweet time to spin around while it zips around the sun.
Exactly.
That's wild. What would it be like to experience a day on Mercury?
Okay, imagine this. You're standing on Mercury,
Okay.
and the sun is rising. It slowly moves across the sky.
Mm-hmm.
But here's the weird part, okay? It appears to get bigger and then smaller as Mercury gets closer to and then further away from the sun in its elliptical orbit.
Wow.
So after about 88 Earth days, the sun finally sets.
Oh, okay.
But that's not the end of the day on Mercury.
Really?
Because of Mercury's slow rotation, you'd have to wait another 88 Earth days, a whole Mercurian year, for the sun to rise again.
That is completely mind-blowing. A year on Mercury is the same as a single day-night cycle. That's incredible.
It's pretty wild, isn't it?
It makes you appreciate the regularity of Earth's days and years. We've learned so much about this seemingly insignificant planet. It's
Yeah.
dense, has a battered surface, hides ice in its shadowed craters, possesses a surprisingly strong magnetic field riddled with magnetic tornadoes, and has a day longer than its year.
Yeah. There's a lot going on there, even though it seems so small and insignificant.
Right. What stands out to you about Mercury?
Oh, that's a good question.
What surprised you the most?
What's truly fascinating to me is that even though Mercury is small and seemingly simple, it exhibits incredibly complex behavior.
Right.
It challenges our assumptions about planets
Hmm.
and highlights the incredible diversity of worlds that exist in our solar system.
Hmm.
And then there's the lingering question about its early history.
Oh, right. Yeah.
You mentioned that Wikipedia discusses evidence suggesting Mercury might have had a magma ocean early in its life.
Right. And it also mentions that weird terrain on the opposite side of the Caloris Basin we talked about earlier.
Right?
Do you think those two things could be related?
It's an intriguing possibility. Imagine a young Mercury, its surface a sea of molten rock, gets slammed by an object large enough to create the Caloris Basin.
It's like a cosmic drama playing out on a planetary scale. You've got this molten world still forming, and bam! A massive impact creates the Caloris Basin, sending shockwaves through the young planet.
And those shockwaves converge on the opposite side,
Yeah.
creating that jumbled, chaotic, weird terrain.
It's a dramatic illustration of how a single event, billions of years ago, can leave a lasting mark on a planet.
It really makes you think about the immense forces at play during the early days of our solar system.
Yeah.
It wasn't a peaceful time, that's for sure.
Not at all. It was a period of intense bombardment and geological upheaval.
Right.
And Mercury, despite its small size, has witnessed it all.
It's a silent sentinel holding on to the secrets of the solar system's chaotic past.
It really is. But by studying those secrets, the craters, the plains, the ice, that strange magnetic field,
Right.
we can start to piece together the story of how our cosmic neighborhood came to be.
Exactly. And who knows what other mysteries Mercury holds.
Right.
Every mission, every observation reveals something new.
Yeah.
It reminds us that even the smallest, seemingly insignificant objects in our solar system can hold profound secrets, waiting to be unlocked.
Secrets that could change our understanding of planetary formation, the distribution of water in the solar system, and maybe even the origins of life itself.
Absolutely.
It's incredible to think that a planet we once considered just a hot, cratered rock could hold such potential.
It really is. And that's the beauty of science, isn't it?
Yeah.
It's about constantly questioning our assumptions, exploring new frontiers, and being open to the unexpected.
Well said. So, dear listener, as we surface from this deep dive into Mercury,
Chuckles.
I hope you're left with a sense of wonder and a thirst for more knowledge.
It's been quite a journey.
It has. Exploring the extremes of this small but mighty world,
Yeah.
we've seen how a planet can shrink, how ice can survive in the face of scorching heat, and how even the weakest of spins can generate a surprisingly strong magnetic field.
It really makes you appreciate the diversity out there, doesn't it?
It does, and the incredible power of these planetary processes.
For sure.
Well, until next time,
Yeah.
keep exploring.